In this video, we're going to do some practice problems with finding the mean and the median given a density function and/or cumulative distribution function. So we're going to look at two examples, looking at the mean and the median and answering some other questions about these functions. So first one, a quantity x has cumulative distribution function, capital P of x, which is equal to 0.375x minus x squared over 32, for x in between 0 and 4, and then P of x is 0 and P of x is 1 for x greater than 4. And we're going to try to find the mean and the median of x. Before we jump into thinking about the mean and the median, let's talk about this function in general and just explain what's going on here. Note this is the cumulative distribution function, not the density function. If we were to graph this function, we know that 4 and 0 are special values here. We are given that the function is 0 for x less than 0. So that's going to be this green line here. And we know that the function is going to be 1 when x is greater than 4. And then in between, we're going to have some quadratic function. And it's going to look something like this. Part of a parabola. And this is our function capital P of x. Note that it's always going to start at 0, end at 1, which we said something we need for these kind of functions. And we also know that our density function little p of x is the derivative of capital P of x. Or capital P is the antiderivative of little p. So I could find lowercase p of x by just taking the derivative of our function capital P. At least this is on 0 to 4. And that will give us 0.375 minus, bringing the 2 down, a 1/16 x on this interval. And we know that on the other intervals, when x is less than 0, P of x is 0. If we think about the derivative, little p will be 0. And when x is greater than 4, capital P is 1, which means that the derivative will also be 0, which matches with what we need a density function to look like. Density function from 0 to 4, we're going to have some line, a linear function, looking something like this. And we know that's going to be 0 elsewhere. This would be little p of x. All right, so that's just some stuff in general about those functions. But now let's answer the question, find the mean and the median. First, we're going to take care of the mean of this function. And then we'll talk about the median on the next page. So to find the mean, this is going to be equal to the integral from negative infinity to infinity, x, little p of x, dx. And although there's different ways of doing this, we're going to try to break this up into 3 different integrals to kind of see more about this function. We're going to break it up from the integral from negative infinity to 0, x p of x dx, the integral from 0 to 4, which is going to be the interesting one, plus the integral from 4 to infinity. But note that when x is less than 0 and when x is greater than 4, p of x is just 0, which means that these whole integrals are going to 0 out. So the mean itself is just going to be equal to the integral from 0 to 4, x times the density function, which we found on the line above, 0.375x, or 0.375 minus 1/16 x dx. Distributing the x across, we have 0.375x minus 1/16 x squared. And then we got to take the antiderivative, plug in the bounds, and we will be done. So antiderivative is going to be 0.375 divided by 2, which will be 0.1875 x squared minus 1/16 divided by 3, which will be 1/48 x cubed, evaluated from 0 to 4. We plug in the bounds, 0.18754 squared minus 1/48 4 cubed, and then minus plugging in 0, but that's all going to zero out, and we will get a mean value of 1.67, or 1 2/3, which is going to be 5/3. So our mean value here is going to be at 5/3. Now let's calculate the median for this function. So to find the median, we're going to do one of two things. We're either going to look at the integral from negative infinity to capital T of our p of x, that is the 0.375 minus 1/16 x dx, our little p of x, and set this equal to 1/2 or 0.5. Or we can just use our capital P here, and we can say that capital P of t, which is 0.375 times t minus t squared over 32, is equal to 1/2. And we can just solve this equation for t. And if we use the integral, we would just find the antiderivative first, plug in the bounds, we would get this exact thing out. So let's just focus on that second part. Solving this equation for t, first thing we're going to do is we are going to multiply both sides by 32 to get rid of the fraction. And when we do that, we're going to get a 12t here minus t squared is equal to 16. If we move everything to the right-hand side to keep everything positive as much as possible, we will get 0 is equal to t squared minus 12t plus 16. This is a quadratic equation. We can either try to factor this or use the quadratic formula, but note that there's no nice way of factoring this problem. You can try a few, nothing will work out. So we have to use the quadratic formula to solve for this. So that's going to be, take negative b plus or minus the square root of b squared minus 4ac all over 2a. Here, a is 1, b is negative 12, c is 16. So that's going to be negative 12, which is positive 12, plus or minus square root of 12 squared minus 4 times 1 times 16, all over 2 times 1, 2a. And then we just need to simplify this. This will be 12 plus or minus the square root of 144 minus 64 over 2. 12 plus or minus the square root of 80 over 2. This is the same thing as 12 plus or minus the square root of 16 times 5 over 2. The key thing about 16 is that's a perfect square. So I could write this as square root of 16 times the square root of 5 over 2. Square root of 16 is 4. And now I can cancel out a 2 out of every term. I will be left with 6 plus or minus 2 root 5, which is approximately two things. This is either 1.53 or 10.47. But we don't have two answers here. We know that it's not the 10.47 because our initial thing says that we're looking at just from 0 to 4. That's where all the interesting stuff's going to happen. So since this is greater than 4, we're not going to deal with that. And that means that our median is the value 1.53. So we are doing the median problems. We're going to be solving an equation. We may have some quadratic factor, maybe not, but we might have to do some algebra to solve those equations, and there's lots of different ways that we could do that. That's a much different thing that we have to do for the mean problems. So let's do another practice problem looking at mean and median. We'll look at some other things as well. Here we'll have an actual application. We're going to look at X is going to measure the time in hours that a student has to take to complete an exam. All students are done within 2 hours, so there's a max time students are done, and that's going to give us the density function for X, which is little p of X is 6x to the 5th over 64 when X is in between 0 and 2, and 0 otherwise. Again, you can't take less than 0 hours to complete the exam. We're saying that you can't take more than 2 hours to complete the exam. So the first question here is, what proportion of students take between 1.9 and 2 hours to finish the exam? Note that this has nothing to do with mean and median, but is simply an integral problem. This is from 7.1, that we can find this proportion, this percentage, this probability by looking at the integral from 1.9 to 2 of the density function 6x to the 5th over 64 dx. So we need to take the antiderivative here. That's going to be 6x to the 5th, or we can do a 6/64th x to the 5th, times a 1/6 x to the 6th, that's x to the 5th, the antiderivative. And note that the 6's cancel out. Evaluated from 1.9 to 2. So rewriting, this is going to be 1/64th x to the 6th from 1.9 to 2. So plugging everything in, we're going to have 1/64th 2 to the 6th minus 1/64th 1.9 to the 6th, which will come out to be approximately 0.26. So what proportion of students take between 1.9 and 2 hours to finish the exam will be about 26% of students. Which means that most students are probably taking a longer time to finish the exam than are doing it very quickly. All right, now let's think about mean and median. First question, what is the mean time for students to complete the exam? So to find the mean, that's going to be the integral from negative infinity to infinity, x p of x dx. We don't really need to look at negative infinity to infinity, as the only interesting values here that aren't 0 are from 0 to 2. So we're going to look at the integral from 0 to 2 of x, and then our p of x, which is 6x to the 5th over 64 dx. A different antiderivative to do. Here we have a constant 6 over 64, x to the 6th dx, which will give us a 6 over 64 times a 1/7 x to the 7th evaluated from 0 to 2. The constant's going to be 6 over 64 times 7, which is 448 x to the 7th, evaluated from 0 to 2. Plugging it in, we're going to have 6 over 448, 2 to the 7th, minus 6 over 448, 0 to the 7th, which will come out to be about 1.71. And here we have hours is our mean time. Stated before that we probably have a lot of stuff at higher ends of the test taking time. And here we're kind of affirming that with the average time being 1.71 hours. Let's look at the median. So in the previous problem, we were given capital P, the antiderivative. We already found the antiderivative previously, but we'll just do the problem as a whole with the integral here. So the median, we're going to look at the integral from negative infinity to capital T, P of x dx. And we're going to set this equal to 1/2. And the median is going to be the value of T. So rewriting this, we don't need to do the integral from negative infinity to T, but instead just 0 to T. Our P of x is 6x to the 5th over 64. And we're setting this equal to 1/2. We found that the antiderivative of 6x to the 5th over 64 was x to the 6th over 64. Evaluated from 0 to t is equal to 1/2. Plugging in the values, we're going to have t to the 6th over 64 minus 0 to the 6th over 64 equals 1/2. So we have t to the 6th over 64 is equal to 1/2. We're going to solve for t. So we're going to multiply both sides by 64, which will give us t to the 6th equals 32. And then to solve for t here, we're going to take the 6th root. So we're going to say this is either t is equal to the 6th root of 32, or we can write this as 32 to the 1/6 power. Either way, you get the same answer, and that's going to be about 1.78 hours. Similar to the time that we got for the mean, which means that this is not going to be very skewed one way or the other. That concludes our videos for the Chapter 7 material on probability. And we'll begin talking about functions of two variables in the next chapter.